As a CCNA, you are expected to know what a VPN is and what we can use to protect our VPNs. That is it. So we are not going to spend time configuring, verifying anything in relation to VPNs, though that would be heavily covered in security courses. But if you take the Encore course, you will cover VPNs there. I will teach you how to set up IPsec site-to-site VPNs, and I'll also teach you how to set up GRE over IPsec tunnels in Encore. So if you're interested in IPsec site-to-site VPNs, a crash course in that, Encore will do that for you, as well as if you're interested in GRE over IPsec tunnels over the internet between your headquarters and your branch offices, then I'll show you how to do that as well. And then we could even get into when we cover DM VPNs. DM VPNs are in RC if you're interested in DM VPNs. All right. But what do we got to do here? We got to walk away from here today knowing what a VPN is, the options we have with Cisco from a very high level. In addition, what we're going to use to provide the security we need. So VPN stands for Virtual Private Network. And please, 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 don't fall into the trap, like many other people, and think that VPN means security. That's not what it means. VPN means Virtual Private Network. Private just simply means it's for you. It's intended for you. Private doesn't mean encrypted, doesn't mean hashed, doesn't mean anything like that. It simply means private for you. And so if you don't set it up right, then it's definitely not going to be safe and secure. VPNs can definitely be unsafe and unsecure. So for example, GRE is a type of VPN. But GRE by itself is not safe and secure. And that is something you can use over the internet. So GRE over the internet is dangerous unless you use it with IPsec. Now you have a secure type of VPN, which is called GRE over IPsec. Did you know that VLANs are actually a type of VPN? That's right. VLANs allow us to create a virtual private network on top of this network we have. Do you ever think of it that way? Probably not, but it's true. VLANs are a type of VPN. And our trunks allow us to tunnel that traffic as well for the different. And how do we do that? All we're doing is encapsulating. And that's what VPNs do. They encapsulate the traffic. So a VPN can be safe and secure or a VPN cannot. It depends on what you're setting up. So when we talk about VPNs in this sense, we're talking about setting up VPNs across an untrusted network. Untrusted. And give me an example. What is untrusted? The internet. The www world. That's what we're referring to in this particular case. It's untrusted. So when you're doing it for this purpose, right, the VPNs you set up have to be safe. They have to be secured. Now, you have the ability to set up site-to-site VPNs. Many different ways to do that. We're not going to get into that. We're not even going to talk about the different ways. But when you do a site-to-site VPN, what's your goal? Your goal is to create a VPN from the site to your other site. So from headquarters, let's say, to your branch office. And the tunnel, the VPN tunnel, goes from the edge interface on that device, a branch, to the edge interface on some device at headquarters. Now, these could be adaptive security appliances, next-gen firewalls. They could be specific devices you get from whatever vendor to set this up. It could be VPN concentrator, right? Whatever, doesn't matter. Just a simple router as well. Fact of the matter is that you got to terminate the tunnel on both ends. You got to make that connection. And you got to do so correctly. Now, the advantage of using a site-to-site VPN is the fact that when you're in this office, as long as you're in a network that is permitted to use that tunnel, you can use that tunnel to get back to headquarters. So it's a very scalable solution. I have a new user that comes into the branch office. We just hired them, and they're going to need to access resources in headquarters. So as long as I'm putting them in a proper subnet, a proper department with the right roles and responsibilities, then they automatically are going to get access to this site-to-site VPN to access the resources they need. And because I'm using the internet, it's only costing me what? my internet connection price. So low cost, it's scalable. We can take advantage of broadband speeds. Folks, today's day and age, how easy is it to get a 1 gig connection for your office? I know where I live, it's super easy. I can get a 1 gig connection to my home. Actually, I can get a 1.5 gig connection right to my home. 1.5 down, 750 up. That was not even a dream 10 years ago. 10 years ago, what was it? What do you mean I can get 10 megs down? Well, more like 12 years ago. Right? So depending on where you live, you can actually get some superior speeds at very cheap prices compared to what we used to pay for the speeds we get. And security's on you, though. You get to control the security. And that's going to be through like IPsec or SSL protocols, or frameworks, I should say, in order to do that. Now, with the remote access VPN, what is that? That is about setting up your VPN tunnel from a single device back to that router, switch, firewall, whatever you have that is able to terminate that VPN on the other side. So you need software running on this, like the Cisco AnyConnect client. So the Cisco AnyConnect client is the device that is the beginning and ending of the tunnel on your platform. Now, again, low cost, because no matter where this worker is, they can make a connection back to headquarters. So it doesn't matter what type of internet connection they have. As long as they have an internet connection and they can connect back to that Cisco ASA, that software is going to be able to do that for them. So low cost, and it's scalable as well. Why? Because no matter where they are, they can use it. But based on our policies and procedures we have in our organization, anytime I build a laptop, I can slam that AnyConnect client on it and set up the customer's profile on it, or the user's profile, I should say, and they're good to go. So there's not really a whole lot of work to add more and more and more and more and more. Yeah, down the road, maybe that ASA might be a little overburdened, but it's scalable to the point that we can keep making connections to headquarters. And we can take advantage of those speeds from anywhere we are in the world. And security, again, is going to be using those different services that we have available. So when it comes to securing our VPNs, we have IPsec and SSL that can be utilized. Modern day deployments are typically using IPsec, but at one point we really relied on both. We used IPsec for the site-to-site VPN tunnels, and we relied on SSL for the remote access tunnels. Why? Because SSL is the same thing we're using to secure our web browsers, those e-commerce transactions. It's called SSL TLS. Anyways, because mobile devices, laptops, PCs already supported SSL, and the SSL protocols could easily be used to encrypt and decrypt without overwhelming those devices, SSL was commonly used for remote access. IPsec, requiring a lot more CPU compute capacity to encrypt and decrypt, typically used for site-to-site. But today, the algorithms we have for IPsec deployments now are amazing. And they are more powerful than they were 10 years ago, yet require less computing power to operate. Meaning that I can get really, really, really strong encryption and hashing algorithms using IPsec on my remote access products, phones, tablets, PCs, laptops, and create remote access VPNs using IPsec as well. So we're seeing a lot more of IPsec being utilized for both remote access and site-to-site because of advancements in the algorithms for IPsec. But regardless, these provide us with things like confidentiality, integrity, authentication, anti-replay protection, key management things. So the big ones here is confidentiality, integrity, and authentication. Right? Confidentiality is about what? ensuring that the data is encrypted. It's protected. So that way there, if it's ever captured by a third party, they cannot see it, read it, use it. They would have to decrypt it first. And we have strong key management techniques in place, and we're protecting our keys aggressively, then they're not going to be able to read it. Especially if we're using great algorithms, along with strong keys and stuff like that. Then the likelihood of them being able to decrypt it is next to none. Data integrity is about what? Ensuring that data is not modified, in transit in this case. So as the traffic's crossing the VPN, we want to make sure that it's the same data that was sent that is being received. So that way there, we can confirm that as it crossed over that untrusted network, nobody grabbed it, modified it, and then resent it onto the network. Origin authentication is making sure that the source and destination of the channel are authentic with each other. So that way there we don't have some third party hijacking that section and putting themselves in there and then actually being that tunnel. So this ensures that the source and destination of the tunnel, not the users that are talking to each other, the tunnel itself, are authentic. Anti-replay protection means that our packets are sequenced as they cross the VPN. So that way there, when they arrive at the other side, it can be verified that those are the right packets. So packet 1, 2, 3, 4, 5, 6, 7, 8, and the order matters. Why? Because what we're trying to see here is if any of those packets are replayed or were captured, held, detained for whatever purpose. So if all of a sudden I'm getting 1, 2, 3, 4, 5, 6, or sorry, let's try that again. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, there's 3. And then continue going. Okay, well, wait a second. We might have a problem here. What took 3 so long? So 3 could have been captured, used, and replayed. Right? So if there's enough of a delay there, we can restart that entire transmission. What else can we do here? We can make sure that if things are arriving out of order, right? Or if things are arriving again, that's what I should say, based on sequence numbers, then we know that they're being duplicated. So let's say we receive 1, 2, 3, 4, 5, 6, 3, 7, 8, 9, 3 arrived twice. That's a duplicate. Duplicate means copied. And possibly somebody modified that second packet number 3 and is trying to gain entry for some reason. So anti-replay protection. Ensuring that if we are subject to a man-in-the-middle attack, right, we're able to detect that and stop that and start over if we have to. So, very important. Now, when we're dealing with something like IPsec, what I want you to remember is that IPsec is a framework. And when we say framework, it means that it's not telling us how to do it. It's telling us what we can use. So that way there, when we are actually doing it, we have many choices. So if we're using IPsec, first and foremost, we have to pick a protocol. So IPsec is not a protocol. IPsec is a framework, IP security framework, protecting packets. So IPsec protocol, we have 2 protocols. We can either pick ESP or AH. Now, the difference between the 2 is that AH only does integrity checking and authentication, whereas ESP also does the confidentiality on top of that. So for site-to-site VPNs and remote access VPNs, you're definitely going to pick ESP no matter what. So you might be saying, well, when am I going to use AH? Well, here's a good example. With OSPF v3 and address family OSPF, that's what it's called, address family OSPF, you don't use the built-in OSPF authentication anymore. You actually use IPsec authentication header, and you use a hashing algorithm instead for authentication. But we don't need encryption. So when we're dealing with just a scenario where we want to authenticate in our own environment without needing encryption, then we'd use AH. But for site-to-site VPNs, remote access VPNs, we also need the encryption, ESP. Confidentiality, many different encryption algorithms specified. Today and age, you're not going to use DES or triple DES, right? Not at all. And you're going to use AES, but there's also other types of confidentiality algorithms that are out there that are even far superior to what we have here as AES. That would work really well on mobile platforms as an example. Same thing with data integrity. MD5, SHA-1, SHA-2, no, SHA-256 today, SHA-512, other options that we have available to us in today's day and age. Origin authentication, pre-shared keys, not for production. Definitely going to use RSA keys instead. And then for key management, Diffie-Hellman, and so on and so forth. So you have all these different options that are going to come into play when you're using IPsec. You pick what you want. So IPsec is there to protect our data, right? IPsec is going to be transporting our data for us in a very safe and secure manner over that site-to-site VPN or over that remote access VPN.